All right, we're going to go ahead and get started here. Welcome to the third Lightning Talk session of the day. Thank you all for coming out to enjoy the Lightning Talks, and thank you to the folks on the live stream for tuning in. We've got a great set of Lightning Talks here set up. In the interest of keeping things on time here, we'll just jump right into it. I've just got a couple of housekeeping items for y'all. If you haven't been in the Lightning Talk sessions yet, welcome. Just so you know what's going on here, we're going to have presentations that are 4 minutes long, followed by 4 minutes of Q&A. For the speakers in the room, if you could help us stay on time by sticking within those 4 minutes for your presentations, that would be really helpful for us and the other speakers. And for the audience, if you have questions, please keep the questions short. Speakers, keep the answers succinct, and we can keep within that 4 minute a window and try to fit as many questions in there as possible. And finally, please wait for the microphone to be passed to you before you actually ask a question. That way, the folks on the live stream can hear what you're asking about. I think that's pretty much everything. So with that, please give a warm welcome to the host of this session, Michelle Lee.
Thank you, John. Thank you to all of the ops team who are working so hard over the past 2 days to make this wonderful series of talks happen. I'm pleased to now turn it over to Matilda, who's going to be speaking about activist models of decentralization and their relevance for web theorists.
All right. I think you're already Oh, yes, I am. Whoopsie daisies. Thank you, Michelle. So, yeah, I'm Matilda. Nice to meet y'all. Y'all can hear me okay, I'm hoping. Okay, good. So I'm a community organizer. That means that I build relationships, and that's basically it. But a lot of that is the minutia of going one-to-one, finding people that wouldn't be found otherwise, and rallying them in a way that we all are going to be able to work together to find something we need, build power together. And I want to distinguish power from authority. Power is something that we can hold collectively. Authority is something where we're going to have the power to decide what happens, write what happens, and then it's going to go be recorded. We are not going to be authors. We are trying to leverage the world around us so that we can just meet our needs rather than control it from the top down. And the internet was not designed that way initially. The internet, by and large, was rooted in the military's need to protect itself in the case of a nuclear disaster. By decentralizing a network, if a city like Washington, D.C. went dark after a nuclear strike, you could still maintain communications between other cities effectively. Now, for a lot of activists, the state is not going to be your friend. Sometimes it is, but a lot of the time, you're going to be grilling them. And we've often had a lot of trouble with the internet, and where we do use it, we have to use centralized resources like Facebook more often than not. It's not something that we're able to maintain ourselves or develop ourselves. And the fact that we're unable to do so belays the strong history of decentralized work that we've been doing. For myself in particular, I was trained in the tradition of Ella Baker, who is arguably a much bigger influence on today's activists than the paradigm here in the US, Martin Luther King. A lot of people think of Martin Luther King as the one who was standing up for everyone's rights, reigniting the promise of America. He was massive figurehead who was in many ways chosen, great as he was, by a group of people who were already privileged within their own movement. Ella Baker was pushed out of the civil rights mainstream, for her work trying to decentralize the movement, allow students, people without power in it, to work locally. And it's her legacy that I wish that we can bring to our work decentralizing the web, rather than letting figureheads, letting our history be rewritten through single points of failure. Martin Luther King, as powerful as he was, as radical as he was not remembered that way. Ella Baker's legacy, however, has been consistent because she was working to distribute power. She isn't the authority on what happens, and that's exactly why I want us to be working with her legacy and the chain that goes back, so that we can rebuild the web, rather than looking at these concentrated figures in history that allow us to write without reading. So that's as much as I can fit. Questions, y'all? Give me some. Lots of them.
What do you think Ella Baker did that we can emulate today, or what is like most effective?
Yes, the lightning aspect of the lightning talk. So Ella Baker was working behind the scenes. She wasn't trying to gain as far as she could to handle the gritty details where they needed to be handled. She didn't trust eloquence when it was packaged and smoothened. When people were trying to make somebody look very, very clean without any fault, she wanted to embrace our messiness. She had to make compromises, and we're all going to have to, but we also need to make sure that we're not going to be hiding those compromises as we go along, and that we are going as far as we can for the people around us, even and especially when they aren't sharing power with us. That's what she did. That's what I have to do in my work, and that's what I hope people will do here as well.
Compared to a figurehead like Martin Luther King in the movement, how effective was Ella Baker?
In the short run, she was by and large forgotten. In the longer run, though, she was able to carry her influence to contemporary movements like Black Lives Matter, which are networked, decentralized, do not have any central authority figure. And it's the long run that we need to be thinking about here. When you're working in the field, you can't really work in the short run. We don't want those quick and dirty fixes. You gotta be taking in everything in front of you, because you're gonna see if there's a failure in a brand new, shiny area, to find the people who are first to see those. Job to make sure that everyone else can see them.
One more quick question.
Yes.
So aside from looking at the work of perhaps Ella Baker, are there any other scholars, either theorists or practitioners, that you would recommend either reading or looking at their work?
So if I had more time, I would have loved to go into the history of Quaker congregations and their role in the anti-war movements of the past. a lot of the time, their work tends to be pushed under the rug, while Christianity is labeled as some cruel, oppressive force. I think that some of the congregations and their way of breaking away from powers like the Pope were some of the best examples of that force in American history. That's America. I would look at the revolutions of 1848 as well to show where if one group is looking at another, even if they're not coordinated, they still know how to network and learn from each other all the same. Rojava as well is an interesting one, but I have to stop there.
Thank you so much, Matilda. Let's get a big round for Matilda. And we are getting ready to welcome our next speaker, Chris Gebhardt, on unity and interoperability amongst decentralized systems. So please give us a moment to switch over the mic, and then the stage belongs to Chris.
Hi, everyone. My name is Chris Gebhardt, and I'm here to introduce my project InfoCentral and its foundational philosophy and namesake, infocentric architecture. So the project was kind of born out of my frustration with a lot of software and database technology, kind of desire to return to first principles. And the kind of underlying idea is to try to make information the center of all computing, with networks and software coming around it in support. And I define decentralized information to that effect as not being tied to any external authority or system that would reduce its reuse in other contexts. So some of the project inspirations have been information-centric networking, semantic web, and then of course some futuristic ideas, pervasive computing, and other things. The central philosophy, as I said, is to let software networks evolve around information so that decentralized projects can compete on quality of service instead of while sharing the same data. So the core of it is the persistent data model. Everything is immutable. Everything is by cryptographic hash reference only. And the data model entities support payload encryption and signing by default, also versioning and annotation metadata, along with other metadata to support semantic web data. This is kind of a rough block diagram of the standard data entity, which is the foundational data structure. Entities reference each other by hash only, both in the header and metadata. And so networks can then collect and propagate references among data entities, not only seeing what they individually point to, but also the incoming references from other entities. And that's the critical innovation in that area. So here we have some particular network or repository knows of two aliased hash values of some entity, and it knows that there are two document revisions that point to it, and also an annotation. So then, like I said, networks, a lot of different strategies for how this kind of information could be networked, both the data itself and also the reference collections. Of course, dereferencing itself becomes a quality of service issue with if you're only using hash references. Ultimately, the goal is sort of a different model of computing that is free of applications. I call it post-application architecture. The idea is that we're trying to move away from like static pre-designed applications where there's a lot of UI and other concerns all baked in together. Try to move to more of a dynamic user environment where users interact more directly with open graph data, can create their own interactions, and everything is dynamically rendered in a local UI framework. Here's an example of like a hypothetical, like a local restaurant has a lot of graph data surrounding it. It has a menu, it has a service queue for customers who want to get in line. And the key issue is that this idea of interaction patterns is basically they're contracts for how users interact with open graph data. Because everything is hash reference, everything can be overlaid without any conflict. So there's, say in the example of getting in line, customers can individually annotate, so it's say like a queue entity, and then a user or service run by the restaurant can then approve that request and then assign them a place in line. On the right, you see maybe customers already at the restaurant could be playing a trivia game. That could be like a third-party interaction brought in from another different context and overlaid. So the idea is to get around shared semantic data as like kind of universal interface. So these are some of the core components as a data management foundation, information environment, and I don't have time to get in that. Gotta wrap this up. Early applications, collaborative hypertext, archival, media management, and scalable discourse is the one I really care about. It's having like communities around information. So anyway, any questions in it?
Is there a type system, or is the system agnostic to the actual
It tries
semantics
to
of the
be
data?
as agnostic as possible to allow different programmatic data types.
I was part of a conversation a couple days ago where people were discussing privacy data, the implications, and everyone in the group arrived at a solution of decentralized data store. So have you been in contact with any groups who might be using this type of solution or collaborating with them?
Not in the real world, I think.
Okay.
Yeah.
I will try to connect you to those people.
Awesome. Yeah.
Your approach seems to share a lot of aspects of blockchain programming. How is it different from like a standard blockchain implementation then?
So it doesn't use, it's a generic graph model. It uses hash referencing, but it's also not a directed acyclic graph. It's basically, well, it is in any given context. It's still, your hypothetical forest of trees. However, it's the cross links basically in the local scope, bidirectional links, because of networks that are collecting the references can, on a local scope, can traverse both directions. So you can see where the incoming links are from. And that's a little different than sort of a top-down DAG approach, where there's sort of like a signed route that goes out to, and that's useful for a lot of things, in particular, like supporting large data. That's definitely part of the model for that use case. But it's not a blockchain in the sense of like a particular single branch tree, if you will.
So while we're unplugging Chris, James Prestwich is going to join us. Hi, James. Everyone say hi to James on the live stream. Hi, James. And James will be speaking with us on Riemann, cryptocurrency development for humans. Take it away, James.
So green. Oh, that's okay. Yeah, left and right. Okay. We good? Perfect. So this was supposed to be a nice shade of pink, but we ended up with bright red. My name is James Prestwich. I work at SUMA. SUMA is a Delaware Public Benefit Corp with the purpose of building free and open source tools for transacting in cryptocurrency and financial instruments. So we make a few products right now, most of them are coming out. We recently open sourced a library called Riemann, and it helps you build transactions on 20 different cryptocurrencies. So you write your code once, and it just works with 20 different blockchains and 40 different test nets. So we can do this because almost all blockchains share a standard data model called the unspent transaction output. And that's just a fancy way of saying some money. Like on a blockchain, we just put some money in a pile and call it a UTXO. It's actually pretty convenient. And when we talk about UTXOs, we call it out points. This is how we put a label on a specific pile of money. So, you know, UTXOs are some money, out points are this money right here. And so all we have to do to move Bitcoin around is point to the pile of money that we want to move and show that we're allowed to do that. And, you know, all cryptocurrencies that use the UTXO model today have a standard data format for it. And so we can, oh, that's so bad. Sorry. I actually just screenshotted my text editor, and I promise I don't use a bright green background. So because everything uses a standard data format and a standard transaction format, when we want to move money around, we can use a single tool to do it for any blockchain. As long as we can get the out point to the money we want to spend on chain, we can just use all of this right out of the box. So we wrote Riemann, and we gave Riemann an interface called Simple, which does what it says. It makes it simple. So when you want to make an input, you point to the pile of money you want to spend, and you just say, our input is made out of that pile of money. And when you want to make an output, you want to put the money somewhere else, you say, how much do you want to move, and where is it going to? And you can also add this nice, cute little message. This is the Unicode for the heart emoji. So we have a nice optional flag. You can just add hearts to your Bitcoin transactions. So, you know, we've said we want to move this pile of money. We want to move it over there. We want to put it in that address. And we just say, make a transaction that moves this money from here to there. And it's really easy. It takes like 5 lines of code to do that. And it just works for 20 different chains. So in the future, we're going to add some more like nice tooling, like automated signing for simple transactions. We're going to help you work with cryptographic keys. We're going to release a whole different library that, you know, does this for you. And it's going to be based on something a lot more secure than Python 3. But, you know, this is where we're at right now. So again, my name is James Prestwich. I work at SUMA. We're a public benefit company, and we make free and open source software for moving money around. Questions?
What language would you So when you're working with cryptographic keys, you want to use a language that can support like secure allocators. And so we're probably going to end up binding libsecp, which is written in C mostly, into Python to work with that. Brian over there did a lot of work on the Python ECDSA module, which is pretty good. But
and now he'd like to use JavaScript.
Mm-hmm.
Would you like to be the maintainer for that Python ECDSA library?
No, thank you.
Oh, damn it.
Yes.
What other projects is Sumo One working on?
So we focus on kind of cross-chain contracts. We do exchange and options and futures and other kind of more complex structured products between chains.
Is there a plan or even a need to do something like this for account-based systems?
So that's going to be awfully difficult considering every account-based chain out there uses a completely different everything. We can do this because we leverage the inherent similarities between all the existing UTXO chains.
Thanks.
Right, and I think I'm out of time. Thanks so much, everyone.
Thank you so much, James. Next up, we have Ainsley Sutherland, who will be speaking on the Enigma Privacy Protocol.
Oh. Thank you. Do I just need to keep going? Okay, here we go. Let's hope you enjoyed that. That's my presentation now. Okay. Yeah, so I work at Enigma. Enigma builds secret contracts for blockchain apps, which means that they're like smart contracts, but the data inputs are encrypted all the way through the computation. And this allows applications that would otherwise have public data on-chain to keep that data private throughout their usage. One of the use cases that we've been really interested in is voting, because it seems like one of those applications that has a lot of qualities that make it exactly not ideal for a blockchain. For example, the votes are public, permanent, and linked to your voter address, which means that bribery and things like that can be contractual. Vote coercion is very easy, and in situations where votes are rewarded financially, voting with the herd can be a winning strategy, and that's relevant for things like token curated registries, which are hot right now. So this became quite interesting to us because we think that the input data of vote is something that's a good use case to be encrypted all the way through the computation. So we wanted to create private voting that enables you to have an app that means that no one knows how the user can vote, and that same user cannot prove how they voted to anyone else. And this does two things. It preserves privacy and also preserves the integrity of the vote itself by knowing that you're preventing bribery and coercion. So private voting means that the votes are correct but never public, and that voters are unable to reveal their vote even if they want to. So we set out to make a demo to kind of show how this would work on our testnet. And what you see here is, I'll keep going quickly, it's a pretty standard setup for voting where you kind of generate tokens. There's nothing right now to prevent from Sybil attack or anything like that. It's very simple. You submit them to a voting contract. You encrypt your vote on the client side, and then you send your encrypted vote, which is the direction of your vote, yes or no, 0 or 1, as well as the weight, the number of tokens that you're committing to that vote, to the poll structure. And then it's sort of, when the poll is concluded, when everyone's voted, it's sent to the Enigma network where the encrypted vote directions are decrypted, tallied, and only the result of the tally is returned to the network. So it's pretty simple implementation. This is just kind of a sample dApp that we built. And then all the data that you see is whether the poll is rejected or passed and by what margins. But you don't see how individual addresses voted. This is our really beautiful front end that we have so far for it, made by one of our engineers, Andrew Tam. I put his Twitter up there in case you guys want to talk to him or see the GitHub repo. But yeah, it basically works as a standard voting poll does, except you have the votes so that you can trust that they're correct, but they never actually are on the blockchain unencrypted. Which is cool because a lot of apps right now are like there's a lot of applications where you'd want to ensure you know who's voting and have identity attached to that address in some fashion. And once you start doing that, you start de-anonymizing your address and linking it to your decisions and your actions in these polls, which can be undesirable for reasons that many, many years of history have shown us to keep voles. Sorry, I just called poll and vote a vole. My mistake. We want to keep privacy in voting. So yeah, so that's what we've been working on. There's a few other methods for maintaining privacy in blockchain-based polling and voting apps. One is called PLCR, which stands for Partial Lock Commit Reveal. And this allows you to hash your votes during the course of the poll and then reveal them later. This prevents you from knowing which way people are voting as the poll is taking place, but it doesn't protect privacy after the poll has ended. And the other thing that emerged about PLCR is it requires 2 user interactions. So you have to both commit and then you have to reveal. The nice thing about our model is there's only 1 user interaction. So we got something for free that we didn't think about, which is it's a simpler experience for the user in addition to preserving privacy and preserving the integrity of the poll itself. I have 10 seconds left, but I am ready for questions. Cool. Yeah, hi.
I saw on the flowchart, what is a SGX node?
Yeah, so our testnet, the way that we handle encryption is that we're running a network of SGX nodes, and then they have a listener to the Ethereum network, and then it passes the computation encrypted to the SGX node. And Intel SGX node stands for Software Guard Extensions, and it's a hardware chip. And so a node will be selected by a random lottery, and then whatever node is selected performs that computation and returns a result. The private key of the node is never revealed outside of the node itself. But the client, the user has to have the client installed so that the client communicates with the node to get the public key. So that's how that, yeah, second question. Oh, a follow-up for that one, shocker.
Yeah, follow-up. Are you aware of the graphite NG?
Yeah, I think we're using, is it graphene?
Graphene?
I think we use that in our tech stack, but
it allows like arbitrary computations in SGX, I think.
Yeah, I think that's what we're using. So, because I know you can do arbitrary computations in the network. So, yeah, which makes it a little bit simpler than SGX nodes. Question?
Yeah, what provisions you have to keep it from being hacked?
Sir, Mike.
Sorry.
How do you prevent this from being hacked externally?
Intel SGX from being hacked, we don't do much to prevent it. Right now, has the hardware the chip is in, actually has no control over the chip itself. That's how SGX works. So, right now for this type of.
Really interesting work. Have you all taken a look at some of the recent research that came out of Cornell about almost like the opposite, using SGX to actually destroy the integrity of a vote, and how does that kind of attack interplay with your system?
Yeah, so there's two things that I think are really interesting about that. He's referencing something called the dark DAO attack that I think Phil Dyan wrote about recently, and it's the idea that you can actually use an SGX to kind of create these DAOs, so to speak, that actually are untraceable because people basically encrypt and share their private key with the dark DAO via SGX. The way that you would probably counter something like that is through the use of an SGX-enabled wallet on the client side so that you can prove that your system saw the private key, and that would make it so that you know that someone's not voting by selling their vote to a dark DAO. But I think there's also, I was talking to some people from Aragon recently and just kind of brainstorming about the dark DAO is also an interesting mechanism to use in situations where you need to have the membership of an organization be private for other reasons, like safety. of its members and things like that. So I don't know if the dark DAO will always be like the dark DAO. It's got a bad name, but it may be an interesting tool that people use in the future for SGX, but it's actually probably going to be addressed by a wallet solution, which is something to explore, but isn't something that we have in the works at this time.
Thanks.
Yeah.
I think that's time.
Time. Ainsley for president. And as we unplug her, we'll get ready for our next speaker, Tantek Jelik, whose name might be familiar for folks who have been working on the web.
Sure why it, you know what? I think I hope it works there. Okay. Good enough. This is the slides I got. Okay, sorry about that. Hi everyone, my name is Tantek Jelik and I work for Mozilla. I'm also co-founder of a community called the Indie Web. And just going to leave this up for a second. I'm actually going to go over to the whiteboard. I figure you all have seen plenty of diagrams like with dots and arrows and segments and stuff, but I figured I'd draw one more. One of our hopes for the original web was that it was going to be an actual web of everything, you know, interconnected, peer-to-peer, all that. But that's not what actually happened, right? The web as it was originally turned out to be an open but very much a client-server architecture. In other words, you had all these websites, and then you had the actual computers that people used that connected to them directly. So really, it was all client-server. Even if you went and accessed the web page from one site and it had images on another site, it still went to your client and went back to the server. Each one of these centralized nodes, of course, what that's going to cause us to happen is the situation we have today, where everyone is accessing the same small handful of websites from their devices. And we know these as our social media silos. So, why is that a problem? Well, social media silos, as we know, if you were at Tristan's talk yesterday, you know that there's a lot of problems with them. There's beyond like loss of expressivity, loss of identity, silos would take your identities away, loss of data, DMCA takedowns, other takedowns, or you lose everything from site deaths. So worse than that, what we found out is we actually lose our focus, we lose our time, we lose our self-esteem, even lose our reason. You look at arguments on Twitter, loss of civility, and worse, loss of safety with all the harassment and abuse that happens on social media these days. So the proposal is to use your own site instead, and that's what the IndieWeb puts forth with a set of principles. Now, that's kind of a challenge today because how do you leave all those social media silos and actually own your data? Well, you have to start somewhere. So one of the key things you can do is actually build your own site and use that as well as social media. So that's what we encourage a lot of people to do. And then the key there is to, once you've built your own site and others have built their own site, is actually to federate between them instead of just talking through some social media central silo. So we do that with a set of building blocks. And the building blocks that are key for this is like, first of all, you want to stay in touch, so you send copies of information to the silos. So here's an example of a post that's on my own website, but also a copy of it on Twitter that links right back to it. Here's an example of a GitHub issue that I filed on my own website, automatically cross-posted to GitHub as well. So the other piece of this is getting the feedback, and that is comments from all these different social media silos. Like you see a post here, and it's got comments from Facebook, from Twitter, all those, and we call that process backfeed, which you can do. But more importantly, the peer-to-peer piece is the piece that we're really interested in. That's web mention. And with web mention, you can get, that's one of our key building blocks, all kinds of comments back and forth. It's a W3C standard. Here's an example of a post. It's got lots of likes and comments from all kinds of places, from Mastodon, from independent websites, from different websites, all via web mention. Here's an event that's got RSVPs, peer-to-peer, also via web mention. So these are built on other building blocks like microformats. And there's a great article about sending your first web mention that I'd like you all to check out. So that's all I've got time for today. I'm willing to go into a lot more detail about how IndieWeb works, but these are the key building blocks to just get started owning your data. And if I could leave you with one message, try to post on your own site instead of Twitter. Even if you post, in addition to that, post to Twitter. And try to post on your own site instead of GitHub. Almost every presentation I've seen the past 2 days have had Twitter handles and GitHub URLs. So let's start acting in a decentralized way as well as talking about how to make a decentralized web. Thank you. Yeah.
I feel like maybe it's been asked a lot to you, but what do you do with people that don't necessarily have the technical skills to even think about how to operate a site, even connecting like a domain to some hosted solution, let alone like
right, great question. So the barrier to entry to like operating a site or owning a site is too damn high, right? The nice thing is that in the last couple of years, a bunch of services have popped up, like micro.blog, that from the very launch support the IndieWeb building blocks we're talking about, web mentions, microformats, micropub. And they are literally as easy to sign up for as Twitter or GitHub. So that bar has been lowered to like, if you want to sign up for a service that interoperates with standard protocols, it's just as easy as Twitter now. So the only extra step is buying a domain name and setting it up to point at micro.blog, which they have instructions to walk you through doing. So it used to be a lot harder to like run your own server and all that. That's gotten easy enough that I would bet every single person in this room could set it up within minutes. Yeah.
What do you feel we need to work on to bring this to the next level or drive adoption or make it better?
So we've documented over 1 million web mentions sent across sites peer-to-peer already. That's comments, likes, and all that. And so the next level, I think that the most important things to think about are making sure that these systems all reflect the values that we want, including avoiding abuse, avoiding spam, avoiding, minimizing misinformation and distraction, all the things that the silos have given us. I think the key is that as we expand these systems, we need to test them with each other and make sure that, hey, if someone's abusive, someone can block things. If someone's spreading misinformation, it's easy to filter it or annotate it as misinformation. And I would say beyond that, start with your own website. Like my challenge to everyone in this room is literally, if you don't already have a domain name, get a domain name. If you have a domain name, set it up so you can post simple notes on it, and then send those to Twitter. I've been posting from my own site to Twitter since 2010. Literally at T, every single tweet you see there since 2010 came from my website. And then GitHub issues I started this year, photos before that. So I'd say just start. That's the kind of the approach to the indie web, is to just start with something simple, and then as you find yourself using it more and more, you're like, this is great. I really like using my own website instead of being distracted by social media, and you'll find you want to do it more.
What's the mobile story for indie web? Like, I live on mobile apps and haven't personally found a good solution for mobile indie web.
Great question. So there's two halves to that. So the question is, what's the mobile story? Mobile posting and mobile reading, both of which are important. So the first is that we have this awesome standard called MicroPub, also W3C recommendation, and there are a bunch of different mobile clients. That service that I mentioned, micro.blog, they actually launched with an iOS app, and instead of creating their own protocol from client to server, they just used MicroPub. So you could use their client to talk to your server, their mobile client to talk to your server if you wanted to. Then on the reading side, this is the most exciting thing that's happened in web. Both Android and iOS clients and a web view. These are all free to download and use, and they actually show all the posts you subscribe to in chronological order. I know that's kind of quaint these days, but I kind of like it that way.
Thanks a lot, man.
Yeah.
Thank you very much, Tantek. And let's welcome up our next speaker, who's Gordon Moore. Who has pets here? Does anyone have a pet? Some pets. Digital pets? Who has digital pets? Okay, Gordon will be speaking about bringing pet names to the @names era. I don't know what that means, but maybe he'll tell me what to do about my dog.
Independent software developer. I worked for many years at the Internet Archive on open source web archiving tools. Before that, my startup in the first sort of peer-to-peer era was a decentralized catalog of what was on file sharing networks, and that gave rise to the now ubiquitous magnet link. So I've been thinking about these sort of things for a while. And my talk is really kind of conceptual about an idea that I think needs more attention and can be updated for current decentralized web needs, and that idea is called pet names. And it doesn't have anything to do with your household pets. So that's an important point to make. Naming is hard. It's really hard to get from small, memorable things to really strong names that computers can use. And while you might like to use a centralized service, we've all talked about the problems with that. Censorship, things go away, rent seeking. Pure crypto names are perfect technically, but very hard for people to use. And so there's this necessary trade-off between these two things. You give up one thing to get a little bit of benefit of the other. And pet names was an attempt by many of the people who first encountered this in adversarial social networking situations of how do you never trust another authority for your naming? And what pet names do is the exact opposite of a central authority. Everybody has their own namespace. Everybody says, my nickname for this cryptographic key is this. My nickname for this cryptographic key is that. Sounds incredibly unmanageable, combinatorial explosion of babble, but if you have local loyal software, then it is probably tractable. It's a matter of your friends, every time they mention someone, seeding your client with the names you need, and thus the names travel from person to person. And you can have non-unique names. It's only when people who would try to use those names in the same forum even notice that the names clash, and the software should promote that and make it clear to people. Those are a couple of the key references. Again, this idea is over 20 years old, and the name is about that long. Unfortunately, there's a bunch of challenges with it. This requires this big conceptual leap. I mean, sort of the average user kind of understands, I go to a different service, I have a different name. The names might be misleading. This requires this leap that every name is different for every person. And the user interface is very tricky. Historically, the pet name is kind of bad. It made sense at the time, but it has connotations of either pets or somebody who you're really familiar with. And actually, it's your pet names for kind of rivals and competitors that are maybe the most important on the social web. The early write-ups use examples from that era rather than the current era. And right now, central services like the name lock-in. And so there's no real existence proofs of pet names. But what do we have? We have @names. @names are widespread on the social networks. They're not really a standard. They just sort of organically came up. And they're teaching people what they need to know to use pet names. They're teaching people that an starts software-assisted filling of identities. They're teaching people that your handles vary quite a lot, even from Slack room to Slack room. They're teaching people that sometimes the services run away with your name and you lose your history and you lose your debates. So I think we need to rebrand pet names as personal @names. Specifically, we could abbreviate it as pat names, writing the actual @ symbol in the name, and thus have a distinct name that doesn't carry the baggage of pet names. The key things of personal @names would be to let people on each of these networks set their own names for their correspondence, and then let those spread from person to person and when they are used. Some potential examples of the UI here. If you took something that's like a basic tweet where you trust those names, you could sort of progressively upgrade it so that some names are questionable. Some names might be mutually agreed. If, say, the author and me both have the same name, then it gets an extra annotation which says, hey, we have perfect consensus on this name. If the names are especially challenging, like I already have somebody named Oscar the Grouch, and I receive a message where somebody else tried to say, this key is Oscar the Grouch, I would get a prompt from my client that says there's a conflict here that needs to be resolved. This could resolve a lot of the scams that happen on sort of Ethereum giveaways and so forth. I think there's a lot of benefits here. Everybody gets a locally sensible name. Keys travel behind the scenes automatically to where they're needed. Novel name claims stick out, and deceptive ones stick out. And you see something in your interface when you reach those trust borders, where one group of people use one name, use a different name. I think eventually it even becomes performative, where people use names to warn people about other people, or to pay compliments to other people, or communicate other sort of out-of-band things. I call this company that, I call this person that. So how do we get there? Consider pet names for your distributed web projects. Highlight the problems with service centralized names. Service centralized names, SC @names, are scat names. They're going to scat out from under you, and they're really crappy. So insist on pat names, not scat names. Questions?
It sounds like you're beginning to, you acknowledge that name collision could be a thing, yes. But how would the UI scale, for example, if you have a lot of, if it's very local, you might have a lot of people named Mark or John, and you may end up in a situation where it's not just 2 people colliding, it's like 20 or 30 people colliding. How do you deal with that?
Well, to the extent that those people often interact with each other, they will tend to resolve those in the way we do when we're in a common space. You use a last name, you use an initial, you use a context where they're from. And the act of ever causing a collision causes your interface to advertise it to you. And ideally, because people are now used to the idea that the names are a bit of hypertext, they're a distinct artifact in your comment, you know you can hover over it for more info. You know you can click on it for details. Those pages should include the level of contention and what your friends recommend for that name, or really just what they've used. Essentially, your loyal local client would remember every name you've ever encountered, and thus be able to give you a ranking the moment you first encounter something new. Oh, all my friends call this person this. That's pretty good for me. If I know who they are, I might add an extra qualifier. So I think when this is properly implemented, things sort of auto-resolve in the same way that people reach consensus on new words or a hashtag spreading across the social network.
One of the characteristics that some previous pet name systems have, pet names that I might have for example, an in-law or a loan shark might not be ones that I want to have my system revealing on my behalf. And so there's not just it's a local name, but it's a private name.
I think that's a subtlety that actually is counterproductive to future adoption. I think people should choose a name that they are ready to both use to call it up and no goes out with their comment. Because then there's no confusion that I am actually broadcasting this name. You are sure that you are recommending it with every use. There may be a use for that as well, a private note field, but I do think that should be considered separate than names, because names are inherently for assigning things for other people, pointing to other people.
Have you thought about ways of using some kind of similar visual identifiers for profile images to distinguish ones that you've approved of or your friends are approved of?
Yeah, I think you could use the same sort of thing. The original pet name write-ups talk about pet images as well. You know, people who have personally met someone might very well click on it and say, I definitely approve that metadata field, but the UI issues for that are even more complicated. So yeah, definitely usable, possible.
With Mastodon and Matrix?
We're seeing an explosion of hierarchical names with the double ats now in the Mastodon new social space, and you know, I subtly used a different one that I like a little bit more on the first page here, Gojomo at Twitter. But yeah. So yes, that's a challenge.
Thank you so much, Gordon. Our
Hello, so my name is Eva. I work at Omise Go, doing strategy and research. And Omise Go basically is building a public, decentralized, scalable financial network to enable global and financial access to financial services. Among other things, so we're building the OMG network, but also developing an e-wallet software developer kit, so companies that don't necessarily want to build their own wallets can connect to our network seamlessly. So this is a pretty common sentiment. You know, why are we focusing on even transferring large sums of money when, you know, basic transfer of any type of currency globally or even domestically between different banks is very challenging. And why is this? So we currently have a lot of financial providers that have very different roles and are siloed in the roles that they play themselves. But even within the roles, you have disparate financial providers that aren't interoperable and really aren't incentivized to be interoperable because they can charge, you know, exorbitant fees. So some of the major challenges with these centralized networks is, firstly, the lack of interoperability, like I mentioned. So banks, you know, aren't incentivized to work together, and so make it very difficult, either because it's costly or timely. There's a lot of lack of transparency. So one bank to another, they might not even have enough information between themselves on what's happening with your transaction when it's in flight. They can be very expensive, as I mentioned, so especially remittance payments, and then that price also varies by rail. A rail being the payment network or route, and there's 12 in total globally that we use, and they can vary in the time and the cost trade-off that you're making. They can also serve as a single point of failure, so as we know, things like Equifax hack, and so your data at that central authority is potentially manipulatable. And then lastly, centralized systems, they create few winners. So either they are in a monopolistic or oligopolistic environment, and they also choose who their customers are. And so that's really the major problem, is that we don't have global financial access. You know, if you are a little bit less attractive as a customer, you may not have access to a means to secure your funds or transfer at all, and that proves difficult in us, you know, enabling globalization, but also having, you know, minimum financial impact or the ability to connect with the rest of the world if you don't have access to a financial provider. So When we think about the global impact, the unbanked population, half of it is in 7 economies, and largely that's focused in Asia. So Omisego is actually based in Thailand, and so these 7 economies, some of them include China, Indonesia, India, and Pakistan. And so we're really focused on not only enabling financial access for people who have money, but how do we touch the people who may not currently have access today. And thinking a little more about some of the challenges that they experience. So the Foundation for Development and Cooperation in Asia actually did a study in Indonesia to see what it would be like if you were in a rural area. How would you get access to a bank? And some of the challenges they experience is physically the roads, like it could take you 2 weeks to get there. Additionally, they actually came across a crocodile. And so people are putting their lives at risk to even make it to a bank to either collect remittances or make any kind of payment, which is just absurd. So we can replace these centralized authorities that either control the system or control who even has financial access, and enable a distributed system where we now have decentralized decision makers. And so some of the mechanics that we're thinking about is network validation through multiple nodes, these nodes being similar to the decision makers, validators of transactions, and so instead of having a central authority making the decision, you can have all the nodes working together and providing consensus. This consensus can be enforced through incentive mechanisms, and so if you process an invalid transaction, there could be some penalizing behavior like a slashing condition, and so making sure that all transactions are accurate and also people's funds are secure. And lastly, making a permissionless network. Oh, I have to stop. Okay. I guess the last thing, if I go. So the OMG network is basically creating a scalable network in the sense that we want to make low-cost transactions, enable low computation and user-friendliness through the ecosystem we're building by also developing an e-wallet and a decentralized exchange mechanism. So the ultimate objective is to have scalable payments using Plasma architecture. I don't know how many people are familiar with Plasma, but basically a child chain that's connected to Ethereum that acts as sort of like a transaction batcher. So you don't have to have every single transaction process on the main chain. You can have a batch set of transactions that exit together and they share that cost together. And then enabling that user friendliness through the ecosystem we're creating, enabling currency agnostic payments and anyone to be able to access it as long as you are access to a wallet. Yeah, thank you. Any questions?
All right, I guess I'll go. So how would you decentralize the consensus validators, be they miners, stakers, whatever the mechanism is? Because that's been a big concern for a lot of people trying to drive the transaction costs down.
Yeah, so in the context of the OMG network, we had an ICO launching an OMG's token, which is the staking token. So on our Plasma chains, the consensus will be proof of stake. We airdropped a significant portion of our tokens, and so they are in the hands of the people. And so it'll be decentralized in the sense that you can stake in staking pools, but ultimately it'll be dispersed among participants.
What are some major pain points or dragons that you've encountered while doing this on this project?
So we're still building. We're currently on internal testnet. In terms of the dragons that I expect, I think reaching the end customer is the biggest problem. I call this sort of the crypto onboarding market, which is people who currently may not even trust banks just because they don't have that trust built in. So how the same in Indonesia on how to actually reach people. And so your messaging, your driver, you can have everything. Pay them in cash and they top up your wallet, or you pay them in cash directly. But the biggest challenge, because enabling people who already have a crypto wallet or people who are very open to digital wallets is pretty easy. It's those who don't have those trust systems and really stick to cash because they don't trust the fundamental institutions that have operated in the past. Yeah.
Speaking of on and off ramps to cash and digital payments, have you looked at how mobile phone credits are used as a currency essentially in other countries outside the U.S.?
So I haven't looked at that specifically. I'm optimistic that they, like with a non-fungible token or really any kind of ERC20 you could create, I'm confident that users, if they trust that currency, they'll also be able to use this kind of platform for that. I think it's interesting, like especially in Asia, loyalty is a huge thing. Even batching through bill payments and like paying in certain types of credits from your lifestyle app is a huge deal. So I expect that some of the currencies we see being used for on-ramping are those kinds of
Yeah, what I meant to say is like currently, if I owe you $5, it's a pretty common practice in some countries to just send you $5 equivalent in mobile phone credit.
Mm-hmm. Yeah, I mean, that's definitely something to look into. I would say like the issue still stands of whether people who currently trust cash are willing to even somehow put that cash onto another system by trusting new kinds of people. So right now, that might be a bank, but if they were unbanked initially or don't trust their bank, now that might be agents that are just regular everyday people who can top up their own balance through them. And I think that's an interesting new market and dynamic, but it'll be, I think, a dragon at the beginning.
All right, thank you so much, Ava. Our final lightning talk for today, for this afternoon's first block, comes from Charles. Charles, are you here? So Charles will be speaking about scuttlebutt apps in about a minute as we get him wired up.
Hello everybody, I'm Charles. I'm going to demo some Scuttlebutt applications. Secure Scuttlebutt is a peer-to-peer social network database, and I'm going to try to show a few applications. Scuttle Shell, I'm going to launch now. Patchfoo, which is a user interface and a general purpose interface, and Git SSB, which is Git repo hosting on Secure Scuttlebutt. So, I have launched Scuttle Shell, and I'm waiting for that to load. And there it is up there. It has a tray icon. So this is a relatively new thing where it can sit in the tray now, so you don't have to launch it from the command line. So now I'm going to connect to Patchfoo, which is running locally. So this is a fairly bare bones interface, but I made it to work in this Dillo browser, which is a very lightweight and fast browser, good for Raspberry Pi computers like this one, and this is useful for off-grid scenarios where you have limited power, for example. So we can go to the public feed here and see some recent activity. And I'm going to start receiving messages over CJDNS, and we'll see them appear in the live feed soon. So I'm going to publish a message now, and you can see it. No, I'm going to publish it in our channel. Here we see some live messages appearing now. So it's syncing with other peers in the network and getting these messages. And this one is publishing still. So each app thing here is a person's feed or identity. So we use a key pair as the identity identifier in the network. And we use pet names. So thanks to Gordon for the the talk earlier, and that was useful for me to learn about theoretical origins of that term. But we are using that here. So this person here has this name Moid, and I can go see what names they've been given. Okay, I'm going to stop CJDNS because it uses a lot of CPU. Okay, so one person, he named himself that 1 year ago. Okay. So this message published, there it is. Now I want to also show you Git SSB. So Git SSB is, okay. Well, I can't show the local one, but I can show you some other things. So I'm going to the source for patchfoo. Oh, yes. Okay, so we can see here the only remote for this repo is this SSB URL. And I can try to clone from that and show you what happens. It uses an integration with Git that you can do to make these custom protocols and fetches the data over secure scuttlebutt. And I've just cloned it. And if I search that up here, it will show you the repo message, or maybe not. Okay, so I showed Git SSB and patchfoo, and there's also SSB NPM I wanted to show you, which is an NPM registry on secure scuttlebutt. So we don't have to okay, I don't have time for that. Questions?
I imagine the Git mapping still uses simply a append-only log of changes. So could you be way behind if the pub you connect to doesn't have the latest pushes from elsewhere?
You could be behind. You may be in a conflict, but the fundamental structure of the network in terms of data are feeds which have messages, and each feed is an append-only log, and the Git repo's contents are reconstructed from the feeds, so they don't have their own feeds unless you make a new feed just for the repo.
And so are the feeds capable of being updated by multiple people with different keys, or yes, not yet?
So it's kind of like a device key right now, but we may have more work in that in the future. But right now it's one feed, it's one identity. But we see some things like you can make a new feed and call it another name, like my name -work or something, and using a pet name. And also people name feeds if they deleted it or it lost the key or something. Any other question?
Since there doesn't seem to be any more questions, do you want to just show the NPM thing?
Sure.
Any more questions? Do you want to just show us the rest of your demo?
Sure. So I'm going to view the Git SSB module using SSB NPM, and also, okay, so that worked. And there's also an integration in patchfoo here to see the different versions. Whoops. Message type. So this is a message here where 4 weeks ago I published this module, and I can go see that, and I referenced it in a post, which is an issue on the Git repo, which is also on the network. And then I can also see the previous versions of the module. So this is patchfoo, which is different from patchwork, which is the main interface that people are using here. But some people use this too. So thank you, everybody.
All right. Thanks thanks a lot for the demo and explanation. That's awesome. So we have one more session after this at 3:30. We're now going to take a brief 15-minute break before we come back for more live streams. So for the folks tuning in on the live stream, thanks for joining us, and we'll be back here in 15 minutes. Thank you so much, Michelle, for helping to host. Big round of applause for the speakers and the host. All right, folks, we're going to go ahead and get things started here. This is the last Lightning Talk session of the entire Decentralized Web Summit. Thank you all for coming out here, and thanks to the folks on the live stream tuning in. In the interest of keeping things moving on time here, I'll be brief. So for the folks who haven't been in one of these Lightning Talk sessions yet, here's a quick overview. We're going to have 4-minute long presentations by Lightning Talk speakers, followed by 4 minutes of Q&A. For the speakers in the room, if you can please stay within those 4 minutes, just so that we can keep things on time, that would be really helpful. And for the folks in the audience who ask questions, please keep your questions short. And then for the speakers, please keep your answers succinct, and so we can try to fit as many questions as possible into that 4 minutes that we have for Q&A. With that, I would like to turn it over to our host of this final Lightning Talk sessions, Amy.
Thanks, John. Hi, everybody. My name is Amy James. I'm the co-author of Open Index Protocol, which is an open and flexible spec that creates a public space that anybody can publish to. And the co-founder of Alexandria, which is the first app built on Open Index Protocol. It's a search all. Everything that's in Open Index is in there. There's other projects that are building more niche use cases. And it is my pleasure to be introducing to the first Lightning Talk of the day, Jay Grabber, who will be demoing a demo of Twitter to Patchwork Bridge. Is he here? She here? Sorry. I didn't.
Trying to get things working here. Okay. I knew I should have brought my MacBook. There we go. Okay. All right, so I'm going to give a talk on social network interoperability as something I think we need, and some screenshots as well. Okay, so right now, a lot of these like decentralized social networks exist basically as little islands that are totally disconnected from the civilizations of Twitter and Facebook. And although I want to use them, I end up on these platforms because they're easy to use and all the people I talk to are there. And so in order to get more adoption, in addition to better UX, I think we need more interoperability between centralized platforms and these decentralized networks. So there's this thing called the Data Transfer Project, which Google just open sourced some code for recently. It's a kind of interoperable protocol for these rather than for individuals. But what I kind of want is that, but for the decentralized web. So you have something in between, or like a library that will convert for you between your data from these networks into whichever format you want to use. So some steps I think that decentralized web applications could take towards interoperability. You can set up ways to help users import their data from existing platforms, help them authenticate their identity, and let them link back to their Twitter profile, their Facebook profile, things like that, and allow you to post back to those platforms. And if you have a user's API keys, authorize those as your application to do that. And then you can also let users choose what they want to hold on to and what to discard. Like maybe make them like a place to aggregate their information and discard what they don't want and kind of like curate it in a better way. So I think one thing that would be necessary to do this would be a library for data conversions for these peer-to-peer social formats, kind of like the Data Transfer Project for the DWeb. So when I first started doing this, it was because I used Patchwork, this decentralized social network, and I used Twitter, and I just wanted some communication between the two. So I hacked my Patchwork client to post to Twitter. So you can see over here the Post to Twitter button. When you post that message, it goes to this test Twitter posted Patchwork. Posted like test a bunch of times, and it was kind of spamming my feed. But so yeah, it is possible, and that's how it would work. And then you can do a Twitter to Patchwork import. So as a user, I can request my data from Twitter. I got the JSON dump of all my tweets, And then I wrote a script to import it into Secure Scuttlebutt, my patchwork client. So now this is an example of a patchwork post that links to my Twitter original tweet on that from Twitter. And so here's the original tweet. And so with that, then I suddenly have some integration between these different identities. And you can like take this a lot further, both for patchwork or for what other social media client I think you're building. So then I was kind of like just working with this, trying to make a little parser for these things. I started calling it Bridge. And eventually, it would be great to have a library for this. Right now, it's just some JSON parsing for Facebook and Twitter formats. But then I started working on a mobile app, because I was like, so much of the decentralized web is built for permanence and built for computers, and we need something that's really usable. So here's an example of React Native mobile app I started building, which does the same thing, gives you posts, Twitter, Facebook, native posts, links back to your networks, gives you a full view that lets you delete the post and view the original. And editing and deletion is something else. I think that social media should be ephemeral. And so decentralized social networks that focus on permanence are, I think, going a bit in the wrong direction. So all the code is here on Patchwork's Twitter, Twitter SSB. Bridge is the JSON parsing. Bridge Mobile was the app, and Bridge Serve is the Go server for that. And I'm Arcalinia on Twitter, Patchwork, and Riot if you want to talk more about it. Right. Any questions?
Do you envision that people would run this themselves, or do you think that there would be somebody running this for a whole bunch of people? How do you think this would actually be operationalized?
I envision it being a library where anyone creating a decentralized social network could use to start making those conversions, or like a like an app, like you can make an aggregator that does this. Yeah, just like different visions of this, but the general principle should be ephemerality and interoperability.
Does this fit in with ActivityPub? Are you publishing to a certain data model?
No, I didn't. So I don't really have like the in-between data model figured out exactly, but I think that you should publish to, like you should have a library that like converts into all these different formats, right? So you have ActivityPub, like Secure Scuttlebutt, like Matrix. I'm sure there's others. So you just want to like do those conversions for as many as you can add in, like plugins, basically.
Well, like IndieWeb, there's that Bridgie, which does something similar.
Yeah? Okay, cool.
So I've used bridging stuff with Diaspora and a couple of other decentralized social networks that build something like this. What I always noticed is that the formatting can be kind of wonky on either side. Like maybe it's cut off halfway and there's like a link that you have to click to like read the rest of the thing or something like that. Do you have it right now at least set up so that it's, you know, it looks like a native post as opposed to something that's clearly not?
Yeah, Twitter is easiest because it's just text and pretty short text. But yeah, of course, I think you'd have to do some integration for whatever. It's just like the data model. I think I've learned more about ActivityPub at this conference. I don't know everything about these different formats. I work mostly as an engineer at Zcash, and this is like a little side project. Yeah.
a warm welcome to Ivan. He's going to talk about his project WeNet, a cooperative P2P cache that helps overcome network interface. Take it away.
Thank you. Thank you. So, well, I'm going to introduce you to WeNet, which is basically a technology that allows users to cooperatively overcome connectivity issues with the upstream web servers. Okay? So, what's the original problem that we want to fix? So, this is Tim Berners-Lee original first ever web server. Okay, as you will see here, it has a sticker which says, "This is a server. Do not turn down. Do not turn off." Okay, so Tim Berners-Lee already knew that the web server not being available is a problem. Okay. I noticed you forgot to turn this on. Let's be fair. Okay. So, fortunately, decentralization, well, the previous problem is because web servers play a centralized role in the web. So decentralization, fortunately, has several issues, several features that helps us overcome that. Okay, I'm not going to explain them here. You already know them. Okay, so with decentralizations, we're seeing really fantastic new innovative solutions. But however, some of them just walk apart or walk away of the established technologies so much that users frequently have issues. Normal users can have a hard time using them, or they at least need to learn many new concepts and ways of using the new technologies. So what we want with WeNet is to provide something that is completely seamless and familiar to the normal web user, so they can just use the same tools, the browsers, the concepts as URLs. For content providers, they can use the normal web servers. We want to have that. To just don't exclude users or require from them a special knowledge or even, you know. So yeah, we want completely familiar browsing. Okay. So what's WeNet? WeNet is basically currently a library that extends web applications accessing the web with new decentralized superpowers, peer-to-peer routing, and distributed caching, which is provided by users themselves. Okay. From the point of view of content providers, it's basically like users became a distributed CDN out of the blue. So typical use case in WeNet is that when somebody is visiting some content, like this ominous piece of news, on their normal browsers, the WeNet library just at the same time uploads this content to the distributed cache, so that if something happens and we start having problems with reaching the upstream web server, this causes the poor normal web users to not be able to reach the content. Then with WeNet, if somebody already accessed this web page, they can retrieve the content from other users, even if it's maybe outdated, because maybe the latest, freshest content is not available because there has been this issue with upstream connectivity. They at least get something. Okay, so in some countries, international connectivity is quite slow, and the user may suffer from that. But not only that, from time to time, there's no neutral pricing of international traffic, which makes it overly expensive. And this can be a bad surprise for users when paying the ISP bill. So with WeNet, since we are retrieving content from different users that may be faster, okay? So it will be cheaper too. So how does it work? When the request from the application powered by WinNet goes to the local client, it decides whether to send it to the origin server or to a proxy over peer-to-peer routing or to the distributed cache. If it's not there, it contacts a trusted injector, which uploads it to the network. It's completely configurable. It's more complex than that. It's on the website. Okay, so technically, sorry. Okay, yes, fine, yeah. Okay. For the future, we still need to work on supporting more backends and that they are resilient to censorship, etc. Not leaking private browsing also, and keep an eye on resource usage for using on mobile phones. That's it. If you have questions. Thank you. Your browsing history or your browsing data, the pages that you downloaded to a distributed public cache. So one must be careful when deciding, okay, this content, I can consider it public and it's fine if it's published, or this is not, I don't want this to be published. So it's completely configurable by the user, but one needs to be careful. That's why we consider still alpha and not ready for everybody to use. More questions? Okay, thank you very much. Thanks.
David? You're next. You ready? You're up? Okay, so this is David, and he's going to give us an overview of the SIA platform. Oh, let's welcome David.
Testing. Okay, there we go. Sure, so I'm going to give an overview of the SIA network today. And so SIA is a decentralized cloud storage platform. It's a place where you can upload your data. It aims to be similar to a decentralized version of Amazon S3. But I want to put it in context of some of the other decentralized data protocols that exist. I think two good examples would be BitTorrent and IPFS, which are decentralized, I guess, sort of file sharing platforms. That may be too specific, but they both suffer from a big issue that they cannot take files which are not meant to be social in nature. So on both BitTorrent and IPFS, a file can only be retrieved if someone is sitting there seeding it, and that is generally an altruistic behavior. There is no reason for someone to take data and seed it, and so this works very well for public files or files that have social value to them. But it doesn't work for private files. For example, if I want to back up my computer, I'm probably going to encrypt it before I post it in a public spot. And then if I put it on BitTorrent or IPFS, no one's going to seed it. So if my machine goes down, that backup's not worth anything to me. So either I have to make physical backups and worry about distributing it manually, or I have to use a centralized service. So SIA sort of solves this problem of there is nobody to host your data. And it solves this problem by using incentives. So where BitTorrent and IPFS are free networks, because of the social aspect, you can expect people to seed certain types of files for free. You don't have to worry about it. SIA is a paid network, so if you put data on the SIA network, you're going to be paying not one person, but a bunch of different people to hold that file. And because they're being paid, they don't care what it is. They don't need a reason to seed it. The money is reason enough to seed it. And then beyond that, we actually have a collateral system. So we don't trust our hosts. We don't want to fall back to a centralized model like Amazon, where we have these trust contracts in place. and that we just have to depend on Amazon. We want to be free of that. So instead of using a name like Amazon.com, we use an incentive system. So before we give files to someone else to hold on to them, we create a contract that we put money into. That's reward for them if they hold on to the files. But we also require that they put money into the contract. So if they want your revenue, they have to take money out of their own pocket, put it into the contract as a sign of good faith, and then that contract goes on a blockchain. So there's no centralized escrow enforcing this contract. It's handled by a blockchain. The contract has a timeline of 12 weeks. The person holding your data has to prove that they still have the data, that they fulfilled the contract. If they do that, they get their money back. They get the money that you promised them. And they don't need you to be there in order to claim that. So you can go on vacation, go missing or whatever. The person holding your data is still going to continue holding their data because the payment is guaranteed. And similarly, you don't have to worry about it because you know that if they disappear, they're going to drop your file. And like I said, we don't trust just one person. Things happen, fires happen, whatever. So what we do is we use something called Reed-Solomon coding. We can take this file, we only need 10, and it doesn't matter which 10, as long as we get some 10 pieces. We can recover the original file, and erasure codes are kind of magical in that this only causes 3x overhead. So that's all I can explain in 4 minutes, but hope you found it interesting. Questions? Sure.
Thanks for coming and giving that overview. What's the application ecosystem look like for SIA, like in terms of user interfaces?
Yep. So we have a couple applications. The most prominent is probably called Mindbox, which is and it was acquired by ClearCenter. It's a NAS solution. So a box that you can put storage in, and so it has extra space on it. Most NASs are typically mostly unused. That extra space gets sold over the SIA network, so you can make money on that extra space. And then the space that is used gets backed up to the SIA network, so that if something happens locally, you have a way to recover your data. We also have an app called GooBox, which is trying to be a decentralized version of Dropbox. So it tries to mimic the UX and feel and easiness of Dropbox, but instead of giving it to Dropbox's servers, it's on this nice decentralized platform.
Ask another question then. Is there like automatic load balancing, or like like one node goes out, but you still want the same amount of redundancy, so another one takes up the contract, something like that?
Yes, so there is auto repair. This is not network side auto repair, and the reason is deduplication. So if the network knows how to shrink and grow the redundancy of your file, it's possible for hosts to reverse that, figure out how to cheat. So your own client has to manage the redundancy and re-replication, but it does do that automatically. And so we generally say as long as your client is running a couple nights overnight per month, it should be able to manage any hosts that go offline. It can repair your files that have weakened redundancy, and so you'll restore them. And of course, the hosts that do go offline get penalized for it.
Just keep asking questions then. Could this be used as something like the back end of a website? So instead of using S3, a developer would just put user content on the SIA network and it can load from a web browser?
Yes, so everything I've described up to this point is stuff that's working today. You can go download and use it. Website support is something we have planned in the future, or CDN support really. So we would envision something like a site like Imgur. Instead of streaming images, or if it's Netflix, movies from their central infrastructure, the movies just sit on the SIA network. The user has no idea that there's a decentralized network involved. They just go to netflix.com, start streaming a movie, and it hits them from hosts on the SIA network. And of course, this is much cheaper, much faster, and more efficient than the solutions that Netflix uses today. But that's not deployed. That is something that is in development.
What are the costs like for users, and what are the rewards like?
Sure. So Amazon typically charges $21 per terabyte per month-ish, depending on volume. On the Scion network for storage, it costs about $2 per terabyte per month. So that's a full order of magnitude cheaper. At 3x redundancy, that means that hosts are getting paid about 70 cents per terabyte per month. So they see 1/3 of that each over the redundancy. Bandwidth, Amazon is typically around $90 per terabyte, although in bulk it goes down to $50 per terabyte. And on the Scion network, I believe right now it's about 15 cents per terabyte. So it's practically zero. And that's all the time we have. Thank you very much.
Thank you so much. That was super interesting. I've heard that the free hard drive space on all of our computers is actually more than if you combined all the CDNs of all of those major corporations that you were talking about. Is that right? Yeah. Yeah, that's pretty cool. Yeah. All right. So you good to go? Yeah. All right. This is Stefan Thomas, and he is going to be talking about web monetization.
All right. Yeah, can you hear me? All right, cool. So yeah, my name is Stefan Thomas. I've been in the sort of blockchain community for about 8 years, and today I'm going to talk about a current project called web monetization, which is sort of a new proposed web standard. But first to kind of explain the problem, like if you're browsing the web today, you probably run into this kind of screen, which is, most websites nowadays, if they're newspapers or even like any kind of free service, there's going to be a lot of advertising mixed in with your content. In fact, if you kind of color it, you can see like all the red areas are advertised. It's almost like the whole screen is taken up with just ads. But and so it's not surprising that a lot of users are actually using ad blockers, and ad blockers are growing almost exponentially. But that's also not really a solution because the websites are actually relying on those ads to make revenue, right? You can't really pay journalists, unless you have some revenue. So how do we solve that problem? And from the perspective of the website, like you shouldn't be able to consume the content unless you're in some way contributing to it. But really, does it have to be, advertising? From the user side, like I want to contribute potentially, right? Like most people that use ad blockers, when they're asked, they actually say that, I feel guilty about using an ad blocker. And I think the rest, they would still say that they want to support the website, there's no good way. And so they feel like they don't have a good option. And so the way we do it today is kind of like this, where if I'm a user, I go to a website, I get basically the content back, and I get a bunch of stuff that I don't want, which is the ads. And that's how the website makes money. And with any other kind of business, whether it's a grocery store or a restaurant or anything else, what you would do is more something like this, where you give me something useful, I give you some money in return, that's it, And what's funny is that actually the creators of the web actually envisioned that it would work that way. So there's a status code reserved in the HTTP standard for paying for the website, you have to pay for this particular page. They just never had a way to actually realize this, and so we're 20 years later or 30 years later, and we still don't have this. And so we I was involved in an open source project called IntelLedger. It's a community group at the W3C. It's actually the 3rd largest community group there, behind WebAssembly and progressive web apps. And it's got contributors from all kinds of backgrounds, from the blockchain community, but also from sort of more traditional finance community, fintech community, even like some regulators and stuff like that are in there. And basically what this community has come up with is this protocol which essentially abstracts away how money moves. So rather than saying like, oh, we're going to use payment method X, whether that X is Bitcoin or PayPal, we're just going to say like, hey, we're going to use IntelLedger, and that could go through X and PayPal and something else and yet another network. Just like on the internet, a packet might go over Wi-Fi and then Ethernet and so on. And so now I want to show you a quick demo of what that looks like. So here I'm in an incognito tab, and I'm looking at a website that has sort of a photo gallery. And in this website, you don't see any ads, and there's some free content, so I can look at a picture, and obviously internet's super slow, so it's going to take a second to load. but I can look at different pictures and that's fine. But then when I want to look at a picture that is marked as paid content, I actually wouldn't be able to look at it. So it says like, hey, I need web monetization enabled browser. And so over here, I have a browser that is logged into a web monetization account and is able to pay. And so now I can like look at the paid picture, and it should, hopefully, if the internet works, yeah, it should pay for it and then show me the picture. And so what's happening here is that it's actually the website telling the browser, please pay to this endpoint, and then the browser makes a paid request to this endpoint and then retrieves the picture from there. So that endpoint doesn't even have to belong to that website. So it could even have like apps that pay other paid APIs and things like that. So yeah, so I work for a company that is essentially, we try to make a flat rate to give you this kind of functionality, but the protocols are all open. So if you want to make your own provider for this, or you want to make an app that charges money through web monetization, you can do that. There you go. Any questions? Oh, in the back.
So when user pays for something, is there a guarantee from somewhere that the content will be served that was supposed to be behind the paywall?
Mm-hmm. Yeah, great question. So I think that with a lot of these kinds of interactions, the amounts are so small that the friction you introduce from adding too many like checks and extra things actually outweigh the value of the transaction itself. So it's kind of like we use the amount of time you spend on the website as a proxy for how much value you get out of it. And I think in the future we might come up with some better metrics. But basically, if you click onto the website and it's like a clickbaity website and you don't get much value out of it, you'd click away, so the website wouldn't make very much money. But if it's an app you keep coming to, then over time they would make a lot more. And we think that that enforces enough discipline to kind of provide a good service.
How does this compare to Brave's approach with microteams?
Yeah, so yeah, sure. So the question is, how does that compare to Brave's approach? So right now, Brave is sort of it's like a platform. So if you're a publisher, you have to actually register. You have to go to brave.com. You have to register. You have to have a relationship with Brave to get paid. Whereas here, there's a protocol in the middle, so you can essentially just call an API in the browser, and the side that's calling it could be any publisher just calling a JavaScript function, and the side that's paying could be any provider. So it's not tied to one particular platform. Yeah, so on the protocol level, it's just a paywall. I think that on the user side, you may want to have a different experience. So for instance, for our users, we want to make it a flat rate. So we pay for everything that you use, like as if it is a paywall, but then you pay us once monthly, and we kind of even it out across users, just the same way that like an internet service provider would, right? So like if you use the internet more, your service provider has more costs, but they're still going to charge you like a flat rate.
I just want to push back a little bit on that. Watch them to view a website. Like ad blockers serve a large like security purpose too.
Mm-hmm.
And usually on websites, it's not the actual website serving an ad. It's like a third party that's collecting tracking data that's sold on some totally unregulated market. And so like that'd be cool if this could just stop all that, but I want to say it's like kind of creepy to say like you should just watch our ads because it's a lot more than that.
Yeah, totally agree.
Have you thought about scaling the pay rates for different types of users? So for example, if the one content is like 1/100th of a dollar in this country, it might be affordable for us, but not for others in different parts of the country.
Yeah, so it's actually kind of interesting because because there's no operator of this platform, it's very much like an interplay between the publishers and the providers or the users. And so, like for instance, if I'm a provider, I can say I want the browser to pay me, and then depending on how much the browser pays me, I will provide this version of the website or that version of the website, right? Or this experience or that experience. And so to implement the feature you said, like that would be up to the publishers to say like, hey, we, the New York Times, believe that content should be accessible to everybody, affordable to everybody, so we're going to charge an IP that comes from a poorer country less than we charge an IP that comes from the US, for example. So publishers could certainly do that. Okay, I think we're out of time. Thank you.
That was a great presentation. Thank you. Sander, who... Yeah. So we'll give Sander a minute to get set up. How are you guys doing today? Yeah? What's your favorite thing from the conference? The lightning talks, naturally. This is Sander, and he's going to be talking about textile photos. You feel like you're all set there? All right, take it away.
I'm going to do sort of a hybrid demo at the same time here. So we build textile photos, and we say that we're on a mission to build really good decentralized user experiences. Seems like that's kind of a common theme with a lot of people. So textile photos is our first experiment, and it is mobile first, offline first, photo sharing and backup. If you guys have seen our booth down the hall, we've been running sort of a live shared thread, we call them, which is basically just a shared photo album. So people have been coming by and downloading our app, which is on the App Store, taking photos, and they're popping up here peer-to-peer. So what is it exactly? So it's decentralized photo backup and sharing. You can post photos, comments, chat is coming soon, all the basic stuff you might expect out of like an Instagram we want to cover. Again, mobile first on the App Store right now. We have a desktop client as well, which you see right here. So this is showing a simulator, of our iOS app, and the desktop client, which is on the decentralized web thread. Content encrypted end-to-end, open source, all the buzzwords for you there. And I'm going to just actually, if I can, exit somehow. Not sure how to exit. I was going to jump to a demo. Anybody know how to get out of here? Huh. Uh-oh. Let me just do this. Computer is frozen, I think. Should be able to. Running too many textile nodes. Huh. Could try and just close it. Huh. Don't know. How do you get over there? Huh. Oh. How do you go back? Well, I guess I'm just going to talk through the rest. So in the last festival, talk about the two main components of a textile node, or the textile project. So we run an IPFS node from Go IPFS, and we wrap it with our application logic. And that's what we call the textile node. And we run bridges to Objective-C and Java bridges, which talk to a React Native library. We build frameworks with Go Mobile to talk to the iOS and Android builds. So the main concept of textile is this concept of threads. So a thread is essentially, it's a hash chain of updates that are committed to IPFS. They're all indexed by each node, so you can do queries and things that any kind of app needs to do. Each update on that chain is encrypted with the thread key and signed by the peers. So, for example, if I was to send an invite to an existing user on the system, they would be able to traverse that chain back, pick up all the other peers that have joined the album or thread, and all the content that came along with it. And the blocks that are on the chain, they might contain pointers to ciphertext and a key to unlock that, which is what a photo is on the textile system. And I really wish I could show you guys a demo, but I'm just gonna have to go to questions, I guess. Anybody? Yeah.
What's in your missing slides?
Well, I was mostly just going to show a demo. Oh. Well, nah, it's all right. So I was just going to join a thread, and then our other them to the thread, and they're going to. Okay. So, let's see here.
So I just created a thread called Standard Live. That's paired to my phone, the desktop app. So you see the Standard Live on the bottom left. And so I can just share a photo into that thread of Standard talking live. And it shows up. So that's the photo I took in 2 minutes ago that I just shared up to there. So that's my thread, private. But you can also do that with other people.
Yeah.
So we have a D-Web Summit one if you want to show people that.
Yeah. So thread it's just a communication channel, so you can push anything over it, and it's a persisted, conflict-free shared state, essentially. So the first use case of it is photos. In our world, we'd like to do chat and audio and video and stuff as well. Yeah.
So you said you're using IPFS for the storage.
Yeah.
Are those files pinned, or how do you ensure that they stay up there permanently?
So you can run a textile node in cafe mode. That was one of my other slides. So a cafe node is very similar to normal textile node. It just opens a user API with the referral codes, and then it will provide a pinning service authenticated with web tokens. So we run, if you download our app that's on the App Store, you will be hitting one of our cafe nodes. You could totally run your own cafe node, and you could run it as a desktop app if you wanted to, or put it on Amazon, wherever you want to do. So, yeah, we'd like to use Filecoin at some point, Jeremy.
What do we need to do to be able to use the app now?
Download it from the App Store, and I'll give you a referral code.
Sweet.
We're in the
and Android. Yeah.
Like monitor setup, we can help you get it all set up.
Yeah. Yeah. I'm way over, so thanks, guys.
All right, thank you so much. Don't you hate it when simple technical problems like interfere with your pitch? When we're on the very edge of cutting edge technology out here? This is Sawwood, and he is going to be talking with us today about interplanetary wayback. All right, here we go.
All right, so I'm Saud Alam, coming from Old Dominion University, that's in Virginia, and I'm going to talk about IP wayback. Everyone was doing something with IPFS, let's say, and basically replay archived content from IPFS. So, so let's introduce what IPFS is. It's a location-independent file system. No matter where the content is, if the content is same, it's going to yield into very same hash. And if you have that hash, no matter where the file is, if it is in the network, you can retrieve that. So that's the basic promise from IPFS. Let's move on to see how web archives work. So there is a very simple HTML page. This is how web browsers render it to us, but this is what programmers write. But when you, what browsers get is basically this thing. So here is the HTML code, but on top of that, there is some extra HTTP header. Web archives try to archive this whole thing, headers and payload. So in order to save that, they can have like individual files for that, but that will require millions and billions of files basically on a file system. That will be a lot to handle. There will be name collisions and so many other problems. So what they do is they take all this header and payload and add extra header on top of that. They call it WARC headers that has more information in it. And this whole thing is called WARC record. And they have many of these records one after the other in a single file. And those files are called WARC files. Then they index it, which URL archived at what date time is present in which WARC file at what offset and how many bytes from there. That's how they serve basically. So we change it a little bit. Rather than saving it in WARC file, we take those WARC files and we cut the response into halves, the payload part and headers part, and we put it in IPFS in two different objects. And if you ask why two different objects, because header has something different in each response. Payload can be the same, so we can utilize the deduplication for that. And then it goes into IPFS, and we get hashes related to those pieces. And we put that in our index, basically. So we create an index that says, this is the URL we observed at this time, and here is the header digest, and the other one is payload. All right? So then in our replay time, when someone looks up for that, we can locate the item in our index and identify those hashes, fetch that from IPFS, combine them, make necessary changes, and serve that thing. So this is how it works. And so far, we basically only decentralize the storage part of it, not necessarily the index part. That we still need that non-distributed index in order to replay that. And we have planned for that. Tomorrow we'll be talking in more details how we can do that. So I think that's about it. And here is something that I archived a few minutes ago. So you can go ahead and replay that. And this is the site. It is running, it was captured about 2 hours ago. So thank you so much. Right on time. Alrighty. I'll take any questions. Yes. Right.
Well, mine's not actually a question. It's just a thank you, because we were very inspired by your work in the WinNet project, regarding how requests are captured, split. We also saved the whole header. So thank you.
Yeah, absolutely. I mean, without that, you cannot recreate the experience. And as a web archivist, we want to not just save bytes, but also the experience. So there is a lot of pronouns information that you want. And so that's why we add extra bit in WARC files, not just the headers that we receive. What time we observe, that's not available in there. The servers can lie about it in their date headers, basically, you know. Yes.
Hey, could you go into how the indexing works a little?
Sure. Currently, we do not index and push in web archives directly. Instead, we take existing WARC files. And why we do that this way? Because there are so many tools already in the web archiving community that create WARC files directly. So wget does that. There is Heratrix that does that, and we have created our own several tools. They're like browser-based crawling systems that basically create WARC files. So rather than going and patching all of them and allowing them to push things to IPFS directly, we ask them, hey, do what you are doing, create WARC files, and we will then push content the way we want in the IPFS system and replay from there. So once we push in the IPFS system and create index out of it, we don't need those WARC files. But WARC files are awesome for long-term preservation, even though we utilize IPFS for replay.
Cool, thank you.
Any more questions? We got a lot of time. All right, so the code is available here at GitHub, and we have sufficiently documented it, how to run it. There is some Docker-based documentation as well. And actually, this is where I'm running right now, the stuff that you have seen. Yes. And this little banner thing that you see is another thing that we added in here. And all these, so these web archival replay systems also require something called rewriting. So if you have a web page and it has images and other resources in there, they might have like absolute URIs or absolute path and whatnot. And based on that, your request might leak from the live web, and we want to prevent that from happening. So if you are showing an archive page, you want everything in there from our web archives, nothing from the live leaks. So to prevent that, web archives generally do it like in server-side rewriting, so they modify all those URLs so it doesn't happen. But things that were injected using JavaScript, it kind of becomes tricky to know in advance from the server how to do that. And for that, we have some service worker in place here, which kind of traps all those requests, makes necessary modifications before they go elsewhere, and kind of pulls it from the web archive. So that's another interesting piece of code that we have written. Yep. All right, thank you. Thank you so much.
That was great. Thank you. This is Chelsea Palmer getting set up over here. And she's going to be talking about the future of decentralized crowdsourced education. That sounds pretty interesting. I think this is our last talk today, if my agenda's right. Yeah? Okay, cool. So you know. All right. Well, once you're ready, take it away.
Indeed.
detecting it. It worked before. That doesn't work for me. There we go. Let's mirror it, and okie dokie. Yep. There we go. Okay, and it's doing the weird color thing, but I don't really care. We're good. So I am going to go kind of higher level since it's a super quick talk, and then during questions, if you want to, I'm kind of pitching some principles that I think are important for the future of decentralized education. And if you think they're improbable or are interested in knowing more concrete, specific, applicable ways to make this happen, ask in the questions. So I am a Vancouver decentralist. I run with a lot of weird, absurdist crowds. We just made DogeCon Vancouver, which was a celebration of radical decentralization. And I will be rapping tonight as Ms. Gnu. I actually rapped at the first Decentralized Web Summit about and inexplicably for Richard Stallman, which like blew my mind for life. So yeah, so I was always a school nerd, and it took me a while to realize that school was not fun for everyone in the way it was for me. And so one of my kind of motivating principles is making education fun for everyone. I've got some pictures here from DogeCon. We had a citywide scavenger hunt where we teamed up strangers to go around and do cryptographic puzzles. That is actually, they kind of thought, this team here thought that that was some sort of physical puzzle, but each of those blocks were sets representing binary code. So there are lots of areas of ideation in decentralization that are not just coding, that are kind of game theory, ethics, etc. And we're looking more and more at design. It's coming up all the time. So getting different minds in the room means doing different types of activities to get people excited. And on the side there we have crypto speed debates between one of our locals, Matt Lockyer, and the CEO of Pied Piper Coin. It's a participatory thing we kind of threw people into to just pick a side in a debate. For example, we had BitConnect versus Ripple. Burn. Yeah, like the idea of just letting people run with things. They will make cool stuff. Now, on the formal side, we actually do need order. Decentralization does not mean disorder, and too often we're like anarchic sovereign citizens as hackers. And so there are these concepts, and I'll post these links later. There are these concepts like acrasia, self-binding, setting goals, and often the easiest way we understand with this, and we see it come up in crypto economics a lot, is skin in the game. The link I have on acrasia, which I will share out because BMinder is on point. There are like put money up against yourself for habit building, like bet money, very simply. And they had this great write-up on just getting yourself to commit. Not many of us have a huge amount of intrinsic motivation in the day and age of memes and screens. Yeah, Cory Doctorow did the keynote at the first eWeb Summit that was on protecting our future most compromisable selves, or protecting our present idealistic selves from the self that wants to eat all the cookies at 1 in the morning. So he did a great write-up of his own talk for that. But I think we look a lot of the time at commercial development of platforms and products as like a Scrum sprint cycle thing. And we don't really look at the order we could put into place for education as well. Like if I just sign up for, if I feel excited about massive online courses and I sign up for 10 of them, I'm never going to follow up. But if I set something into place with my peers where we all kind of put some form of skin in the game together and we have a syllabus shared that we all commit to, then we might follow through there. And I think the commons is necessary for that. And I have just put memes here because I think the only real thriving commons we have right now where people are swapping and sharing and remixing is actually memetic culture. And that's why I'm obsessed with memes. And finally, I think we don't have rituals in our civilization as much anymore, especially post-religion. We don't have coming of age ceremonies, etc. So for DogeCon, we had the State of the Decentralized Union in a UN-style building, and we all dressed up weird and like made a thing of it, and it really made this the super silly formal times thing. Like we can play, especially in this industry, we can play with the old norms of business and you know, goof around with them a little bit, take some of the formality and play with it, because we realize everyone is pretty playful in here. I think you need to reset the timer. Dogecoin millionaire. So yeah, this is something that I think we can all collaboratively design as groups. And I think all the fun, silly stuff is just as important as the code, because otherwise we're not going to get normal users excited. So yeah, if you ever come up to Vancouver, come visit us. 4-year-plus anarchic education space. We want to collab with everybody, and you can find me online. So cool guy zone, please come in. That is my presentation. Any questions? I know it's very abstract, so if you don't believe some of these principles can be made real, challenge me. Because we've designed specific activities.
Well, I have a question.
Yes.
How do you think the Decentralized Web Summit has done?
Amazingly. And that's the thing, is like the gamification, and I think I have notes here that I didn't look at. I meant to mention like experiential gamified learning and stuff from the very first day. You know, we did like the courtyard activities, and there's like the awesome art puzzles and stuff like that. So I think it's keeping everyone refreshed, giving people different ways to still be learning, but not just kind of like, whoa, information jam, information jam. It's doing awesome.
I'll ask another one. How and then pass it to Dogecoin Millionaire. How can we take that fun that we've created offline back online? Because it's also really easy to fall into serious pants mode online too.
That's very true, and that is why I very much lean on memes and GIFs. I mean, in Lightning Talks yesterday, we got into the area of, is it GIF, GIF, oof. Like, you can pronounce it any way you want. But I feel, honestly, that finding ways for humor and art to break up the monotony, and maybe even if we started to establish cultural norms around like, oh, this debate on crypto Twitter is getting way too heated. I think everybody needs to drop their most fun memes and kind of lighten it for a second. It kind of like humor coming in, I think, always will pull us back from excessive drama. Hello.
Can you touch base on a topic, or expand on a topic that I've heard you speak about before, about how the decentralization at Decontrol helps to prevent the commoditization of Decontrol?
Oh, yeah. Okay, so our space in Vancouver, the reason we are a 4-plus-year-old community commons space and you haven't heard of us is because we're this weird, gross little basement with no real official affiliations, and it's been beautiful because business people come down during the exciting, the 20K burst in December and stuff like that, and they're like, ew, I don't want to sit down here, like, why is that sticky? And it's actually protected, like us being a bunch of goofballs renting a basement together. It's also a way, like this levity of goof, like the sociopathic singular focus of like Wall Street style costumes, and we're like, it's kind of like in Walking. But it is something that I really think, like, I think we've been playing a game for a long time where, like, I don't think anyone wants to be that serious, and people kind of were doing this cultural game where we all thought we had to wear suits, and that's changing significantly. So I think we can keep with that trend.
Last question. I wanted to talk about collaborative creation of educational material that the courseware companies, Coursera, Udacity, so on, don't accept updates. They have some ways of sharing translation, but it would seem like there is kind of a quality issue, that what you would like is to have courseware that is produced and is as good quality as a good documentary. But those are elaborate enterprises that are put together for millions of dollars to do a good quality documentary, and yet courseware still suffers from being a kind of replication of the in-classroom experience, except sitting at home.
Yeah, I believe in this as in many things. I think we need to follow the path blazed by open source software communities. if you have like some of the best curated resource lists for learning about blockchain, like Jameson Lopp's Bitcoin Guide and stuff like that, are run off of GitHub with people submitting pull requests. So if we have platforms where our peers can comment and say, hey, I don't think that's a great resource, and we have an open discussion always going on around it, and it can be revised, commented upon, I think that's a good way for us to keep upping our level of shared knowledge.
Excellent. Well, thank you so much, Chelsea, for that super entertaining talk.
Thank you.
That concludes the final lightning talk session that we have today. I want to give a huge thanks to Amy for hosting this one, and to all of the rest of the hosts who volunteered to help. Thank you to the volunteers who have been around the room helping to keep everything running on schedule. Huge thanks to all of the speakers here and in the previous sessions. Thanks to the YouTube live audience for tuning in online. The AV team in the back, like, huge shout out to you guys for being awesome. The staff here at the Mint, the free coffee, the security guards, they're all doing a great job. This was a really amazing event. And so finally, huge thanks to the Internet Archive for helping to put it on, and the sponsors. And of course, to you, the lovely audience, for coming and giving us someone to talk to, people who care about decentralization and really understanding that decentralization is the means to an end, which is a better web for all of us. Thank you for coming and participating in the Decentralized Web Summit.